Good day everyone. Today we will discuss a new lesson about Binomial Theorem, but before that, let us study first Pascal's Triangle. Keep in the back of your mind that we will about to expand a binomial. Just visualize the binomial a plus b always as a parenthesis to the second power. I know that you know how to do that, but what if we get to a higher binomial? For example, we have a plus b raised to 6. You can multiply it manually, but it will test your patience. What if you have a plus b raised to 20? So this lesson will help you solve that kind of problem really fast. And in order to do so, you need to understand the Pascal's Triangle. First, it starts with 1. Then you need to write another 1 to the left and to the right. And it looks like a triangle. This is the beginning. Next, let's add 1 and 1, that is 2. Write again 1 and 1 to the left and right. Next, 1 plus 2 is 3. 2 plus 1 is 3. Input your 1 again to the left and to the right. Next, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then your 1 to the left and to the right. Next, 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And of course, 1 to your left and to your right. Can you follow? Let's continue. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And of course, your 1. Okay, last. For the sake of example, we have here 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. 6 plus 1 is 7. Of course, your 1. The next thing that we need to do is to label them. So on this part, we have here row 0. Next, this is your row 1. Row 2. Row 3. Row 4. Row 5, row 6, and then row 7. You might be asking what is the connection of Pascal's triangle in our lesson, which is the Binomial Theorem. Okay, so let us try to expand a plus b raised to 0. We all know that any value raised to 0 is 1. So let us write our answer here, 1. How about if we expand a plus b raised to 1? Of course, we know the answer will be a plus b. How about if we added the exponent, a plus b raised to 2? We all know that a plus b raised to 2 is also the same with the quantity of a plus b times the quantity of a plus b. And for us to expand this one, we just need to use the FOIL method. So the answer will be a times a is a squared. A times b is ab. B plus a is ab or ba. And then b times b is b squared. And for us to simplify this one, combine like terms. So copy a squared plus ab is 2ab. Then copy b squared. This is now the expanded form or our answer for a plus b squared. So let me put boxes here. Okay. Next, what if we need to expand a plus b cubed? We all know that a plus b cubed is the same with the quantity of a plus b times a plus b times a plus b. And we know that a plus b squared is this one. So let's copy a squared plus 2ab plus b squared times another a plus b. Okay, so let us expand this one. So let us distribute a squared with a, and that will give us a cubed. Next, a squared with b, that will give us plus a squared b. Next, 2ab times your a, that is plus 2a squared b. Next, 2ab times b, that will be plus 2ab squared. Okay, last, b squared times a, that is b squared a. And b squared times b, that is plus b cubed. Now let us combine like terms. So copy a cubed plus a squared b plus 2ab. They are similar, so we have here 3a squared b plus 2ab squared, and b squared a is also the same, so we have plus 3ab squared. And of course, copy b cubed. This is now our answer for number 4, the quantity of a plus b cubed. So what is the connection of this expansion in the Pascal's triangle? So if you can analyze the coefficients from our answers, it is also the same with our Pascal triangle. So let's try to look first with a plus b raised to 0. We all know that any value raised to 0 is 1. So 0, 0, we have here our coefficient 1. For row 1, the coefficients must be 1 and 1. And we have here a and b, and there is an imaginary 1 as their coefficient. Next, for a plus b squared, that is row 2. For our row 2, we have coefficients 1, 2, and 1. 1, imaginary 1 coefficient, 2, and 1. Same with the row here in our Pascal triangle, row 2. Next, the quantity of a plus b cubed. The coefficients here are 1, 3, 3, and 1. Let us look in our Pascal's triangle if we have the same coefficients. So we have here the exponent 3, so we will look at row 3. And we have there 1, 3, 3, 1 as the coefficients. It looks like a magic, isn't it? But what if we have the 16th power? Pascal's triangle is not that cute anymore. So you can use the combination formula or the binomial theorem. What if you have subtraction? Example, the quantity of a minus b. Or what if there's a number in the coefficient? Example, the quantity of 2x minus y raised to 4. Don't you worry because it's basically the same idea. Let me introduce you the Binomial Theorem. And in Binomial Theorem, we have the formula. The quantity of a plus b raised to n equals n combination 0, a raised to n, b raised to 0 plus the combination of n1, a raised to n minus 1, b raised to 1 plus plus n combination of n, a raised to 0, b raised to n, where your n combination k is equal to n factorial all over k factorial times the quantity of n minus k factorial, or just simply input on your calculator nck. So if you will get your scientific calculator, it is present in the division symbol. So just press shift and then this one, division symbol. So this long formula here is the same with this one. Or again, you can simply input this one in your calculator. It is also the same with the quantity of a plus b raised to n equals the summation of n factorial all over n minus k factorial, a raised to n minus k, b raised to k, from k equals 0 to n. Okay, before we proceed with the binomial theorem, let me first introduce to you what factorial means. Let us try to compute the following. Number 1, 6 factorial. When we say factorial, the symbol is this one. It looks like an exclamation point. And it says that we need to multiply all whole numbers from our chosen number down to 1. So we have here 6 factorial. So 6 times 5 times 4 times 3 times 2 times 1. That is 6 factorial. So we need to multiply 6 by 5 by 4 by 3 by 2 by 1, and that is equal to 720. Next, 5 factorial divided by 3 factorial. So we have 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 equals, so this one will be cancelled out, and what's left is 5 times 4, and that is 20. Next, 100 factorial divided by 99 factorial. So we have 100 times 99 times 98 up to 1 divided by 99 times 98 times up to 1, and this will be cancelled out, and what's left is only 100. That is the answer for 100 factorial divided by 99 factorial. Next, number 4, 10 factorial divided by 7 factorial, 3 factorial. So we have there 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 7 times 6 times 5 times 4 times 3 times 2 times 1 and 3 times 2 times 1. So all the way from 7 to 1 is cancelled, and what's left is 10 times 9 times 8 divided by 3 times 2 times 1, and that is equal to 120. So that is the concept for the factorial. Now let us apply the quantity of a plus b raised to n equals n factorial divided by n minus k factorial, a raised to n minus k, b raised to k from k equals 0 to n in expanding binomials. Let us prove the quantity of a plus b squared. Let us expand a plus b squared using the binomial theorem formula. So this is equivalent to the summation of 2 factorial divided by the quantity of 2 minus k factorial, a raised to 2 minus k, b raised to k from k equals 0 up to 2. This is the equivalent summation notation of the given binomial. So let us try let us try to solve this one. Using the binomial theorem, if we will get the same answer, which is a squared plus 2ab plus b squared. So our solution will be that I substitute the following values of 0, 1, and 2 in our k, since our starting point is 0 and we will stop at 2. Two factorial divided by 2 minus 0 factorial, 0 factorial, a raised to 2 minus 0, b raised to 0, plus 2 factorial all over 2 minus 1 factorial, 1 factorial, a raised to 2 minus 1, b raised to 1, plus 2 factorial all over 2 minus 2 factorial, 2 factorial, a raised to 2 minus 2, b raised to 2. Okay. So we started from 0, then 1, and we stop at 2. Next, let us compute 2 factorial, that is 2 times 1, which is 2, all over 2 minus 0, that is 2. So 2 factorial is 2. And then 0 factorial is just 1. Take note that 0 factorial is always 1. So 1 times 2, that is 2. And then we have here a raised to 2 minus 0, that is 2. And then b raised to 0 is just 1, so no need to write. Plus 2 factorial is 2, all over 2 minus 1 is 1. 1 factorial is 1, 1 times 1 is just 1. So we have a, 2 minus 1 is just 1, and then b raised to 1. So let me write this one to avoid confusion. B raised to 0 is 1. Next, 2 factorial is 2 divided by 2 minus 2 is 0. So 0 factorial is 1. 1 times 2 is 2. And then a raised to 2 minus 0 is 0. 2 minus 2 is 0 rather, and then b squared. So let us now simplify. 2 divided by 2 is 1. A squared, because 1 times a squared is just 1. Plus 2 divided by 1 is 2. AB. And then 2 divided by 2 is 1. A raised to 0 is just 1. So no need to input, and then copy b squared. And if we could analyze, we have here our coefficients 1, 2, and 1. Same with our coefficients in the Pascal's triangle. And when we just use the simple FOIL method. Next, let us expand x plus 3 raised to 5. And here we need to apply the binomial theorem with the combination. So first, let us write the combination nk. 5 0 5 1 5 2 5 3 5 4 5 5. Take note that the top number here represents our power number or our n in the formula. And for the bottom number, it represents the k. So we start at 0 and we'll end with 5. N is your power number and then 0 is your k. And in order for us to get the values of our coefficients, we can use this one or just input in your calculator. I will show you later on. Let's continue. The next thing that you need to do is to write your first term, raised of course to our exponent 5. So we have x raised to 5. In this case, class, you need to understand that the exponents of our first term decreases. So if we start with 5, followed by x raised to 4, x raised to 3, x raised to 2, x raised to 1, x raised to 0. The exponent increases. Next, for our second term, 3 raised to exponent 5 as well. But this time, we will start at 0. And for our second term, the exponent increases. So we have here 3 raised to 0, 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4, and then 3 raised to 5. And if we look with our exponents, if we add them, the equivalent is the same, 5. 3 plus 2, 5, 2 plus 3 is 5, 1 plus 4 is 5, 0 plus 5 is 5. And of course, do not forget our operation plus. Now, let us compute. So, 5 combination of 0, let's just use our calculator here. And let me teach you. So, 5 input 5. And then, shift division symbol for our combination. And then, our k, which is 0. And the answer is 1, meaning to say the coefficient here with 5 combination of 0 is 1. So let's write 1. Next, how about 5 combination 1? 5 combination 1 is 5. 5 combination 2 is 10. Next, 5 combination 3 is 10. 5 combination 4 is 5. And of course, if we analyze, the coefficients are symmetric. So if we have here 1, 5, 10, 10, 5, automatically 5 combination 5 is 1. And if we look into our Pascal's triangle, row 5 for exponent 5, our coefficients will be 1, 5, 10, 10, 5, and 1. Okay, let's continue. X raised to 5, that is x raised to 5. Copy x raised to 4, x raised to 3, x raised to 2, x raised to 1, and then x raised to 0. Next, simplify. 3 raised to 0 is, very good, 1. 3 raised to 1 is 3. 3 raised to 2 is 9. 3 raised to 3 is 27. 3 raised to 4 is 81. And then 3 raised to 5 is 243. Plus symbol. Okay, so let us simplify our answers. 1 times 1 is 1. So just copy x raised to 5. No need to write 1 as our coefficient anymore. Then plus 3 times 5 is 15. So write 15, copy x raised to 4. Plus 9 times 10 is 90. Copy x cubed. Plus 27 times 10 is 270. Copy x squared. And then plus 81 times 5 is 405x. And then plus 243 times 1 is 243. X raised to 0 is 1, so no need to include. And this is now our final answer. The expanded form of x plus 3 raised to 5. We have x raised to 5 plus 15x raised to 4 plus 90x cubed plus 270x squared plus 405x plus 243. Now, what if we have subtraction? And there is a coefficient in our first term. Again, just like what I've said, it's basically the same idea. So let us first input our combinations here. So take note of our exponent raised to 4. So start with 4 combination 0, and then 4 combination 1, 4 combination 2, 4 combination 3, and 4 combination 4. Next, we need to input our first term. Do not forget your parentheses and then your exponent. So again, the first term's exponent decreases. 2x raised to 4. 2x raised to 3. 2x raised to 2. 2x raised to 1. 2x raised to 0. Next term, negative y. So raised to 4. But this time, we will start at 0 and ends with 4. Second term's exponent increases. Negative y raised to 0. Negative y raised to 1. Negative y raised to 2. Negative y raised to 3, and negative y raised to 4. Do not forget our operation addition. Okay, next. We need to compute for our coefficients here, and you can use your calculator or you can just simply look into your Pascal's triangle. So in our Pascal's triangle, row 4, since our exponent is 4, so our coefficients are 1, 4, 6, 4, and 1. You can double check it if you want. So we have 1, 4, 6, 4, and 1. Okay, let's compute our first term. Laws of exponent. So we need to distribute our exponent for both 2 and x. So we have here, let me close this with parentheses. We have 2 raised to 4 x raised to 4. Next, 2 raised to 3 x raised to 3. 2 raised to 2 x raised to 2. 2 raised to 1 x raised to 1, and then 2 raised to 0 x raised to 0. Next, our second term, negative y raised to 0, that is 1. Negative y raised to 1 is negative y. So negative y squared, that is positive y squared. Negative y cubed, that is negative y cubed. And of course, negative y raised to 4 is positive y raised to 4. And of course, do not forget our operation here. Now, let us simplify our answer. Before that, let us first simplify the terms here. So, copy the coefficients 1, 4, 6, 4, and 1. Let me show you the steps here one by one. Okay, 2 raised to 4, that is 16. And then copy x raised to 4. 2 cubed is 8. Copy x cubed. 2 squared is 4. Copy x squared. 2 raised to 1 is 2. Copy x. No need to input the imaginary 1 there. And then 2 raised to 0, x raised to 0 is just 1. Next, copy 1, negative y, y squared, negative y cubed, and y raised to 4. And of course, our operation. Okay, so let us now simplify our answers. 1 times 1 is 1, times 16x raised to 4 is only 16x raised to 4. Next, look at the signs here. We have a negative sign and positive sign, meaning to say the sign will be negative. And then 4 times 8 is 32. Copy x cubed and then y. Next, positive y squared and then positive, so the sign is positive. 6 times 4 is 24. Copy x squared and then y squared. Next, plus negative and then positive, the sign is negative. Okay, so we have here 4 times 2 is 8. X, y cubed. And then for the last term, positive, positive, so the sign is positive. 1 times 1 is 1, and then times y raised to 4 is just 1 raised to 4. This is now our final answer. In expanding, 2x minus y raised to 4. So that ends our discussion for binomial theorem. Take note of the formula in connection, of course, with the Pascal's triangle. Thank you and God bless.